Solving systems of rational equations algebraically can be time-consuming and prone to errors. Today, we will explore how to use the Desmos graphing calculator to find precise solutions quickly and visualize the behavior of these functions. Graphing allows us to see the entire landscape of the functions. Instead of solving complex polynomials, we can identify points of intersection, vertical asymptotes, and holes instantly, ensuring we don't miss any valid solutions or extraneous roots. A rational system consists of at least one equation involving a fraction of polynomials. Before we graph, remember that any value of x making the denominator 0 is undefined, creating a break in the graph called an asymptote. When you see the graph shoot off toward infinity, you've found an asymptote. In Desmos, you can manually plot these by typing x equals the restricted value. This helps verify that a solution cannot exist at that specific x coordinate. The solutions to the system are the coordinates where the graphs intersect. Desmos highlights these points with gray dots. Simply click on a dot to lock the coordinates on the screen, providing you with the exact x, y solution pair. Sometimes solutions are hidden or very close together. Use the zoom tools or adjust the axis limits in the settings menu to ensure you have captured all possible intersection points across the entire coordinate plane. Let's try a practical example. We want to solve the system where y equals 4 over x plus 1 and y equals x. By looking at the graph, we can see the line cuts through both branches of the hyperbola. By clicking the intersection points, Desmos reveals our solutions. In this case, we have two distinct points. Notice how the x and y values are equal because our second equation was simply y equals x. Not every system has a solution. If we graph y equals 1 over x squared and y equals -2, the curves never intersect. Desmos visually confirms there are no real coordinates that satisfy both equations simultaneously. Be careful with functions that can be simplified. The function y equals x squared minus 4 over x minus 2 looks like a line, but Desmos will show undefined if you click exactly on x equals 2, representing a hole. If you need more precision or want to check specific integer values, convert your expression to a table. This allows you to compare the y outputs for both equations at exact x intervals to verify your graphical findings. To master these systems, always enter your equations clearly, identify where the function is undefined, click the gray intersection dots for coordinates, and double-check that your solutions fall within the valid domain. Rational systems represent the intersection of complex behaviors. Using a tool like Desmos removes the algebraic burden, allowing you to focus on the relationship between the functions and the nature of their solutions. Look at the screen. If you were to click these 2 points in Desmos, you would find the values that satisfy both equations. Based on the graph, can you estimate where these intersections occur? The solutions are x equals 1 and x equals 2. Plugging these back into the equations confirms that 2 divided by 1 is 2, and 2 divided by 2 is 1. Great job visualizing the solution. You are now equipped to tackle rational systems using Desmos. Use these strategies to verify your homework, explore function behavior, and solve complex problems with confidence. Generated by Vision Solve AI.